Okay, folks, so we're going to do some reviewing of matrix multiplication. You're probably familiar with this, so my best piece of advice is that you go ahead and pause the video and then work each of these problems on your own, and then just check your answers in the video. I think that's best. But just as a reminder, so pause the video and do that. As a reminder, what does it mean to square a matrix? Well, we have to be a little bit careful here because our properties of exponents for the real numbers don't necessarily all carry over for our properties of exponents with matrices, but when we define a squared, what we really do mean is to take matrix A and multiply it to matrix A. So let's go ahead and do so. So I've got one copy of matrix A, which I'm writing here, and we're going to matrix multiply it to another copy of matrix A. And we should do a quick check to make sure that the multiplication is well defined. Keep in mind that not all matrix multiplications are well defined. But here we're okay because this is a 2 by 2 matrix and we're going to be multiplying it by another 2 by 2 matrix. The check is that the interior dimensions are the same, and then our resulting matrix will be this 2 by 2 on the exterior here. So our resulting matrix will be a 2 by 2 matrix. And remember how we're going to find the values. To find, we're going to have there it is, the 2 by 2 matrix. And to find this first entry right here, the 1, 1 entry, I'm going to take, careful, it's the 1, 1 entry. So the first row of the first matrix times the first column of the second matrix. And what we're really doing is we are thinking about this as a vector and this is a vector, and we're doing the vector dot product. That's how we defined matrix multiplication a long time ago. Okay, so let's actually do that. Multiplying this row to this column, I multiply together the 1 times 1 plus the 3 times 2, which gives me an entry for that matrix of 1 times 1 is 1, 3 times 2 is 6. That gives me an entry of 7. If I do the same thing for the, this is, careful, the 1, 2 entry, I'm going to take the first column of the first matrix and the first row of the first matrix and multiply it to the second column of the second matrix. And so that gives me 1 times 3, which is 3, and 3 times 5, which is 15, and that gives me 18 for that entry there. Okay. I'll just do the last two entries just as a reminder. For this entry right here, this is my 2, 1 entry, so I'll take the second row of my first matrix times the first column of my second matrix, and if I do that multiplication, I get 12. And then lastly, for the 2, 2 entry, I take the second row of the first matrix times the second column of the second matrix, and that gives me the entry 31. Okay, so let's go ahead and try B. B asks us to compute matrix A times matrix B. Before we get going, let's check something here. Matrix A we know to be a 2 by 2 matrix because it has, and you can't really get this one wrong, it has 2 rows, that's the first 2, and 2 columns, that's the second 2. So that's why it's a 2 by 2 matrix. But matrix B is a 3 by 2 matrix. Matrix B has 3 rows, that's why it's 3 by, and then 2 columns, so that's why it's 3 by 2, or that's how we describe it. And multiplication then is not well defined in that case. So the check, the quick sort of shortcut check, is to look at those interior dimensions when you set this up, and you would say multiplication is not defined. For a more sophisticated argument as to why it's not defined, you'd actually go to the summation definition of matrix multiplication, or you can, when you think about multiplying for a single entry, a row vector times a column vector through the dot product operation, we defined dot products only to work when we have vectors of the same dimension. So there's lots of arguments as to why that's not defined. Okay, entry C though asks us to find matrix BA, and hopefully we'll be a little bit luckier there. So if we go to compute matrix BA, we're going to go ahead and look at multiplying matrix B by matrix A. Now, the way I set up the matrices before, where I just set one next to the other and I did the matrix multiplication, that works absolutely fine. There is sort of a shortcut for thinking about matrix multiplication. So I'm going to copy down matrix B here. So it was matrix 1, minus 1, 2, 3, 1, 0. I'm going to put it a little bit lower. If you can see how I've oriented this. In fact, I'm going to lower it even a little bit more if this one note plays ball. And then let's go ahead and multiply it by matrix A, which was the matrix 1, 3, 2, 5. And I actually think this visualization gives you a really good understanding of why we need our dimensions to align. So I'm going to have here, well, just to double check the dimensions, this is a 3 by 2 matrix, and this was a 2 by 2 matrix. But here you can see, if I think about, just by the way I've oriented this, I'm going to have 6 computations that I'm able to do in terms of multiplying 2 by 1 vectors together through the dot product. So for this first entry here, I'm going to take let me use a different color on that. For this first entry here, I'm going to take this row multiplied to this column through the dot product operation, and you can see that we end up with, and here I'm just going to go ahead and fill it out for you folks, we end up with -1 when we do that. Let me put that in a different color. We're going to end up with -1 when we do that. For the next entry, we'll end up with -2. For the next entry, we'll end up with 8. Then we'll end up with 2. Then we'll end up with 1, we'll end up with 3. As always, folks, please double check me. Just as a reminder, when I went to compute, say, this entry right here, do that in a different color. When I went to compute this entry right here, this is the 2, 1 entry, so I took the second row of my first matrix and dotted it with the first column of my second matrix. And when I did 2 times 1, I got 2, and then I did 3 times 2, and I got 6. Summing those together gives me that entry of 8. So I hope that clarifies the process of matrix multiplication, and also gives you a reminder as to why, in some instances, matrix multiplication is not well defined. Okay, so the next thing we're asked to do here is we want to go ahead and compute in part D, we want to find A transpose. So while we don't often get into the molecular level of a matrix, we can always think of a matrix as this Aij, where it's just a sequence that has terms that are double indexed. Okay? So when we go to compute the transpose of this matrix, this is what the transpose is. It is Aj. So one way of interpreting that is that we're reversing the address for each of these entries. And so while this was a matrix that was maybe an n by m matrix, this will now be an m by n matrix if you think about how these indices values go. So let's go ahead and just do it. Let's go ahead and compute A transpose. Well, that would be the transpose of this 2 by 2 matrix, which was 1, 3, 2, 5. We're transposing that. And so let's just go through it a little bit slower than we usually do. The 1, 1 entry becomes the 1, 1 entry. So that will still be the number 1 here. And when I go to find this entry right here, that is the 1, 2 entry, but that becomes the 2, 1 entry of my new matrix. Okay? This entry right here, which is my 2 by 1 entry, this entry right here is the 2, 1 entry. It's going to become the 1, 2 entry, so first row, second column of the transpose. Okay. And then finally, let's see here, running out of colors, this entry here, it's the 2, 2 entry. It remains the 2, 2 entry when we do the transpose. So folks, that's a little bit tedious to actually go into that, like I said, that molecular level where we're looking at the kind of the address, the Ij entries. And so there's a shortcut way of thinking about it, but be very careful because it's easy to do this backwards. The net effect of doing this is to notice that the first row in my matrix becomes the first column under the transpose. Similarly, the second row of the original matrix becomes the second column in the transpose. And folks, I apologize, I'm sure you noticed this as you're watching the video. That should have been a 5 for that entry right there. So I'm so sorry. I'll put a little timestamp in there. Okay? Okay, well hopefully that helped to clarify. I'm losing pieces here or there. Hopefully that helped to clarify the transpose operation. So let's try it again in part E here. Let's find B transpose. which is going to be the transpose of this matrix, 1, minus 1, 2, 3, 1, 0. We're taking that transpose. Here it's a little bit easier to notice that the original matrix, B, I'm not pointing at B transpose, I'm just pointing at the B here. B was a 3 by 2 matrix, so when we do the transpose operation, we're going to end up with a 2 by 3 matrix. So this will now be a 2 by 3 matrix when we do the transpose. So let's go through that just using my intuition from before. This row becomes this column. So this will be the column 1 minus 1, and we'll just fill out the rest. This becomes the column 2, 3. And again, I guess I should be more careful. This third row here becomes the third column of my transpose matrix, and so we just enter in 1, 0. Okay. Finally, folks, we have the trace operation. If we wanted to be really careful with defining the trace of a matrix A, what we're doing here is we're going to sum up certain entries. We're going to sum up the entries that look like AII. Notice it doesn't say AIJ. That means that the row and column must always be the same. Which entries along a matrix are the row and column address number the same? Those are just those on the main diagonal, and we do this from I equals 1 to n. So what this is the definition, but in net what it's asking us to do is it's asking us to go ahead and sum up the entries along the main diagonal. Well, looking at matrix A here, which I have written right up here, if we sum up the two entries, we get 1 plus 5, or we get 6 for that trace. The trace operation is not a difficult operation, but if you haven't used it in a while, you might have forgotten it. Folks, that was a quick review of some matrix operations. I hope you found it helpful. Let me know if you have any questions.